Hi everybody, I'm Brahm from Learn with Brahm, and today I want to share with you another solution I found to a video that I posted. That video was called Math Kangaroo Puzzle, and I highly recommend you check that out before watching this video. I'll put the link to that video in the description below. Without further ado, let's begin. So I made the same illustration that I did last time, labeling our 4 points here, and the line that cuts through it, along the center of the circle. So there's nothing much different about this solution, except it takes less time and it's sort of more intuitive. So in the last video, I showed how this point here and the length here and this point and the length here were related, because if you label this 0, y1 and this point 100, 50 minus y1, you would easily be able to find the slope of the entire line given these 3 points. But in this video, I want to share how the center of the rectangle can play into this. And it'll actually make solving the slope of the line a lot easier. To understand the solution, I made another sketch to understand the theory behind it. So you can see here, I have a square, and it's on a Cartesian plane. And its center, C, here, sorry, I'll make that better. Its center C is the coordinate 0, 0. So you can see that these 4 squares make up this larger square, and these 4 squares are congruent. Now, squares and rectangles are what we call point symmetric. Now, point symmetry means that for every point on a border, so on this square, let's say I put here, there is an equidistant point from the center opposite from the center. So if I draw a line, I'll draw a line, let's say here, that crosses through the center, 0, 0, to the other end. This means that as long as the square is point symmetric, these two lines, these line segments, are always congruent, meaning that this point, the center here, is the midpoint of the segment. So there's actually a really easy way to prove that the area that this line cut is the same. So this sort of shape here and this shape here, there's an easy way to prove that their areas are both congruent. So I drew just 2 straight lines, these 2 vertical lines here, which basically cut this line into this triangle here and this rectangle here on both sides. So there's also this triangle here on this side and this rectangle here. So to understand why both these areas are the same, I first need to show that these 2 triangles have the same area, and then how these 2 rectangles have the same area. So both their areas added up would be the same. So to first show that, I'm first going to make a few illustrations. So this triangle here, we can prove that it's the same as this triangle here by side, side, side theorem. So we know that this whole side here, this whole length, has to be the same as this side here, because it's from one point to the top to the bottom, so these segments would have to be the same. And we also know how this length has to be the same as this length here. And we obviously know that this line is congruent to itself. So by side, side, sine theorem, these 2 triangles have to be congruent. Alright, so now we know that these 2 triangles are congruent, but how do we prove that these 2 rectangles are congruent here? Well, the proof that I'm going to show may take a little bit longer, but it's the way that I derived it. So I first took one quadrant here, so you can see how there's this triangle here, and then there's this triangle here. Now I wanted to prove that they're both congruent. So I saw that because we know that this center is the mid segment, or sorry, is the midpoint of this segment here, we know that this side is equal to this side. So we know that that part's the same. We also know that this height here has to be equal to this height here, because this is the center point. So the top to bottom here would be the bisector of this segment here. So this side would be equal to this side. And finally, to prove that this side is equal to this side, I first found that this angle is equal to this angle. And also we know that this angle has to be equal to this angle because this is a transversal. And we know that opposite interior angles are the same in any transversal. So by side angle side theorem, we know that these two triangles are also congruent. And this is very important because that proves that this side has to be equal to this side. Sorry. That side would have to be equal to this side. So this length, show here, this length would have to be equal to this length here. And this is very important for what I'm about to show. So it's important to know that this length is equal to this length. I'm going to quickly label this A and label this B. So we know that this whole length has to be equal to this whole length because this is the bisector of this length here. So if this length is, I can call this length x, so this length would also be x. So we know that x plus b has to be equal to x plus a. So this length x here plus b must be equal to this length x plus a. So that just proves that b must be equal to a, meaning that this length up here must be equal to this length up here. So that proves that these areas are the same because this height has to be equal to this height. So this rectangle has the same area as this rectangle, and we proved that this rectangle here has the same area as this rectangle. So the line that cuts through the center on this on the square will produce every time two congruent shapes. So any line that has any shape that has point symmetry, any line that will pass through its center will always make two congruent shapes. So now we know that any line that passes through the center of a rectangle will cut its two shapes directly in half. So that means that this area would have to be equal to this area if it cut through the center. So all we need to do is find the center of this rectangle and make it so that that point is on the line. And then we need to find the slope of the line between that point and the center here. So all we need to do is find the center of this rectangle. So the center would be from 0 to 100, cut that in half, would be 50, comma, and the height is 0 to 50, 25. So that'd be 50, comma, 25. So I'll put that somewhere here. So that'd be 50, comma, 25. And so now we have 2 points, this point here and this point here. And all we need to do is calculate the slope between them. And you could do it either way, but I'll just take this as y2 and x2. So 75 minus 50, or sorry, y2, that would be 30 and 25. So 30 minus 25 is 5, and x2 minus x1, which would be 75 minus 50, would give you 25. And 5 over 25 is the same as 1/5. And that's our solution. So the slope of this line that cuts this rectangle in half, that goes through this point 75, 30 in this cutout circle, is 1/5. And that's exactly what we got last time. So that's the solution. There was a little bit less math involved, but it required you to know a little bit of geometry. I hope you found this video helpful. Thanks.